So in this last section, we're going to go back and fix a sign mistake I made in that problem that bugged me earlier. We're going to take a look at fractions, and then we're also going to take a look at an application from economics. So if you go back to your notes, we have to fix this problem. Remember we came out with a fraction. I said, I think we should be getting 14, but I couldn't find the sign mistake. Well, I just found it, so we're going to fix your notes. So in the solution, x turns out to be -6. And when you plug in a -6 to solve for y, we'll get -12 minus 7y is equal to 2. Adding 12 to each side, we have -7y is equal to 14, and dividing both sides by -7, we have y is equal to -2. So go back and fix your notes because that solution should be -6 comma -2 and not the fraction we had earlier. But speaking of fractions, so maybe this isn't a type of problem you've had much experience with, so just to make it a little more challenging in pre-calc than in algebra classes that you've had before, what if you have a system that has coefficients that are fractions? The easiest way to deal with these is just to get rid of the fractions. And the way you get rid of the fractions is by multiplying both sides of the equation by a common denominator. So if this is our starting point, and we want to get rid of these fractions, I'm going to multiply both sides of this equation by 6. That turns that equation into 3x plus 2y is equal to 96. And in the bottom equation, I'm going to multiply both sides by, let's say the common denominator, let's say is 12. So we'll multiply both sides by 12. You may wonder, what if I use 24? What if I use a different common denominator? If you do, your equation will look different, but your solution will be the same. So you don't have to worry about which denominator to use. Any denominator is going to be fine. So this would give us 2x plus 3y is equal to 108. And now we have a system that has no fractions as coefficients, and we can go ahead and solve. Now, this is an example of a system where you would definitely not want to use substitution because all of the coefficients aren't 1, and so we would probably use elimination. So why don't you finish that off? Go ahead and solve the system using elimination. And finally, an application in economics, cost, revenue, and profit. So one application of systems of equations is to find what's called a break-even point. So a business has certain costs to stay in business. And a business then also is in business to make money. So they have a certain profit. And this point where you begin to make money is called the break-even point. So up until that point, notice that cost was bigger than revenue, meaning a business was paying out more than it was taking in. But after that point, revenue was more than their cost. And that difference between your revenue and your cost is your profit. This, by the way, is called loss. So when you're spending more than you're making, you're losing money. That amount is called loss. And when you're making more money than you're spending, that extra money is called profit. So let's take a look at an example. A musical group charges, and here's a function for cost, C of x, 32x plus 20,000, where x is the number of attendees at a concert. The venue charges $80 per ticket. How many tickets does the venue need to sell in order to break even? For me, it's often helpful to kind of think about a picture in my mind about the situation. And so if we think about the number of attendees and the money involved, if we graphed this first equation, it has a y-intercept of 20,000 and a positive slope. So this is what C of x is going to look like. And the slope is 32. Now, $80 per ticket, what that means for revenue is if they have 0 attendees, they have 0 money. But as they begin to sell tickets, they make money. And so 80x would be a function that would model how much money they're making, $80 for every attendee. And notice that that line would look like this. It has a y-intercept of 0, but has a slope of 80, so it increases at a steeper slope than the first line. And so we were asked to find the break-even point, in other words, to find this point here. All right, so this is pretty easy to do. We just have two linear equations. One is y is equal to 32x plus 20,000. And the other is y is equal to 80x. This would be a really easy equation to solve for by substitution because this equation is already solved for one of the variables. So we'll simply substitute it into the other equation and solve. So we have 80x is equal to 32x plus 20,000. Subtracting 32x from each side gives us 48x is equal to 20,000. And dividing both sides by 48 gives us 20,000 divided by, let's try that again, 20,000 divided by 48 gives us 416 2/3. So at your 417th person, which would be right here, right past 416 2/3, because 2/3 of a person can't buy a ticket. So at the 417th person, the venue begins to make a profit. Okay, so one example of application of systems is with cost, revenue, and profit, and simply finding the break-even point.